Hi everyone. In this part, I am going to discuss about the maximization of balanced assignment problem using Hungarian method. Steps in maximizing an assignment problem. Step 1. Convert the assignment problem by subtracting all the elements from the largest element. Phase 1. The row and column reduction. Step 2. Identify the minimum element or elements in each row and subtract it from every element of that row. Step 3. Identify the minimum element or elements in each column and subtract it from every element of that column. Phase 2. The optimization of the problem. Step 4. Make the assignments for the reduced matrix obtained from steps 2 and 3 in the following way. For each row or column with a single zero value cell that has not be assigned or eliminated, backs that zero value as an assigned cell. For every zero that becomes assigned, cross out all other zeros in the same row and the same column. If for a row and a column, there are two or more zeros and one cannot be chosen by inspection, choose the cell arbitrarily for assignment. The above process may be continued until every zero cell is either assigned backs or crossed. Step 5. An optimal assignment is found if the number of assigned cells equals the number of rows and columns. In case you have chosen a zero cell arbitrarily, there may be alternate optimal solutions. If no optimal solution is found, go to Step 6. Step 6. Draw the minimum number of vertical and horizontal lines necessary to cover all the zeros in the reduced matrix obtained from Step 4 by adopting the following procedure. First, mark all the rows that do not have assignments. Second, mark all the columns which have zeros in the marked rows. Third, mark all the rows that have assignments in marked columns. Fourth, repeat steps 6, second, and third until no more rows or columns can be marked. Fifth, draw straight lines through all unmarked rows and marked columns. Step 7. Select the smallest element from all the uncovered elements. Subtract the smallest element from all the uncovered elements and add it to the elements, which lie at the intersection of two lines. And now, we are going to perform the given example. A transport company has a fleet of 4 trucks. There are 4 cities where the company wants to send similar consignments after taking into account the route expenses and other taxes. The company estimates that the profit per day for each truck in each day is as below. Find the optimal assignment. So, this is our given maximized assignment problem. So before, we need to convert this matrix into minimized 1. So, kailangan nato pangitaon kung asa ang pinakadako sa ilahang number diri. And isubtract siya sa tanan mga elements pod nga naa sa matrix. So, since si 21 ang largest element nato diri nga table, ato ang isubtract sa iyaha tananing mga numbers nga naa sa sulod sa matrix. After nato ma-convert si maximize table into the minimize 1, mag-start na ta og gamit sa Hungarian method ug magsugod ta sa phase 1, which is the row reduction. To start the row and column reduction, ato ang pangitaon ang pinakagamay nga element ana nga row or column. So let's start with column 1. So since 0 ang minimum element, and if ato siyang isubtract sa iyang other elements, walay ma-change. So nara. So column 2. Since si 1 ang ato ang minimum element, if ato siyang isubtract, 2 minus 1 equals to 1. And 5 minus 1 equals to 4. 1 minus 1 equals 0, and 1 minus 1 is 0. Column 3. Si 1 gihapon ang ato ang minimum element and isubtract nato siya sa yang other elements. 4 minus 1 equals 3. 3 minus 1 equals 2. 1 minus 1 equals 0 and 1 minus 1 is 0. Same gihapon sa row 4 nga si 1 ang ato ang minimum element. Ato siyang isubtract sad sa yang mga kuan and we come up with this. Atong mabantayan nga every column ang minimum element is C0. And if atong i-apply ang row reduction, wala na mabag-o. So sunod nga atong buhaton is to proceed on the phase 2 which is the optimization problem. Column 1. Since siya lang ang 0 sa iyang column, atoa siyang i-box. And if i-check nato siya pa row, na ay other 0 which is ato na ni siyang i-cross. Column 2. If ato ang i-check, na Japon duha ka 0 and kaning first nga 0 ato ang i-box, and atong i-cross ang the other 0. Column 3. Since na cross out na ning first nga 0, and siya na lang ang 0 sa ani nga column and sa ihapon nga row ato siyang i-box. Same goes to column 4. Since siya lang ang 0 sa iyaha nga column and if i-check pa row na cross ng iyang isa ka 0, siya ang ato ang i-box. An optimal assignment is found kung ang number of assigned cells are equals the numbers of rows and columns. And in this case, we can say that we reach our optimal solution. No other way to assign and eliminate 0. And it is kung nag-box ka 0 base sa column, we can eliminate the row horizontally. And if nag-base pud ta by row, we can eliminate the column vertically. From our original table and the optimal solution, we can conclude that our track 1 mas dagan siya halin sa CTA which is equals to 21. Si track 2 mas daghan siya halin sa CTC which is equals to 20 and 2C 20. Si track 3 sa CTB siya mas daghan og halin and equals to 20 and 3B. Track 4 sa CTD siya mas daghan og halin which is equals to 20 also. The optimal profit of the assignment equals 1A plus 2C plus 3B plus 4D. Substituting values from the original table, we have 21 plus 20 plus 20 plus 20 equals to 81.